Okay, in this video we're going to take a look at exercise 5.19. It's called rotate to the array. It could also be called rotate image or rotate matrix. What we basically have is, let's say that we have numbers 1, 2, 3, 4, 5, 6, and 7, 8, 9, right? You can think of this array of arrays, right? So like this, right? And what we need to do is just let's create duplicate. Space this out a little bit. And what we need to do is rotate this matrix. We could either do it like rotate it horizontally or vertically, right? So basically clockwise or counterclockwise. In this exercise, we need to do it clockwise, like this. So this would be our results. So first row from the start is 1, 2, 3, and the output is 7, 4, 1. Okay. So let's just make this guy smaller just for reference. And yeah, let's take a look at this square. We are actually rotating square here. What we can notice is that we have corners. So let's have corners here. So we have 4 corners. And how to solve this in place would be to just save, let's say that this cell is saved to the temporary variable. And then we can just move corners to its new position by rotating it clockwise, right? And after we're done with this cell, we can just move temp to this cell, right? Okay. So let's talk about time space complexity for this one. So for runtime, we could say it's it's n times n, right? Or n. If n represents the number of cells inside the 2D matrix. And for space, we won't be using any additional space here because we will be reusing our matrix. So it's constant. It's O of 1. Okay, cool. So let's just implement this solution and see how it looks. First, let's just change this to an A. Cool. Okay. So let's just create an n variable, which is just length A, and x, which is n minus 1, which represents the last index. Right? We will be having 2 for loops, so for I in range, and now we need to calculate range. So it starts from 0, but it needs to end so we could use math, do it like this. So n basically this n/2 will return us float, and with ceil would give us the upper bound number, right? But we need to import math. If we don't want to import module, we could say that n 2 slashes, which it rounds down and give us back integer, and we can do say plus n modulo 2, which will basically do the same thing as before. And the inner loop is for j in range, and we can do just /2. Cool. Okay, so now the hard part, or the tricky part. So the first cell can be saved to temporary variable. So let's do that, j. And now, okay, so this current variable, let's just do it like this. Okay. Okay, so this is A, I, and J, and we saved it to a temporary variable, which is good. Now we need to look at this cell. So we have A, and it starts with last row and goes upward. So it's last index minus J. And for column, it's I, right? Because it just goes upward. So the rows change in the inner loop. So that's why we need to use J. And for I, it's just column is 0 for the first iteration, right? So it's X minus J and I. Okay, so next one, let's look at this one. So this guy needs to go to its next place and to see what actually is changing here. So we start at the last row and the row stays the same. So it's X minus I, but the column, it starts with the last index, which is X, and minus, it changes often, right? We are changing columns. So we do minus J. So it's X minus I, X minus J. Right. And the last one here, we start with the first row and the row changes often, so it's J, right? But the column, it starts with the last index and the column stays in place. So it's AJ, X minus I. And the last one is just temp. Cool. Let's just run the test and see what happens. Okay, test pass. Like, this exercise is quite tricky because we could just mess up the rearranging or the cells. And another tricky part is when does the range, like getting the right range, right? So yeah, that's it for this one. Until next time, bye.